May 20th, 2024. A year that'll live in history. I want to drill down on microservices because you want to keep a smart agent as small or terse as you can, and yet um, you have to separate out into smart agents, niggling little processes. Where's the right compromise? We know we don't do a big old monolithic program anymore. Well, let's think of a use case. I'm going to use the tic-tac-toe game again, not because that's significant computing, but because it should be down and dirty, easy to do. Um, we've already talked about this. The way I would think about implementing a tic-tac-toe um, game would actually be a matter of images, matter of patterns. That is to say, you start off, you got a blank um, board, right? But as you play, um, the possible images that could be your next step get reduced more and more. Well, it gets constrained because you can't. That's not a valid play, right? So rather than come up with a thinking machine that figures it all out and remembers and yada de yada de, I think simplistically you could just basically have all the a set of all the possible images. And again, with something like Go, that becomes very huge. You can still do it, but it's very huge. And but tic tac toe is a lot smaller. So I guess what I'm saying is to have every possible image that a Go board could have. I'm not even sure what the permutation is, but it's huge. Because a Go board's like 18 by 18, or is it 9 by 9? I think it's Mogoku that's 9. But anyhow, it's like 18 by 18. So multiply those two together as opposed to 3 by 3, multiply those together, right? Gives you an idea of the scalability. So, how would we implement such a uh, D app? Well, I have already fleshed this out in some design. You'd need a game master, keep track of whose turn it is and what the board currently looks at like, right? So then you'd have to have some kind of pattern matching, or almost like bubbling up or overlay or something. See, the game master wouldn't do that. You'd have a smart agent that would be a player, a computer player. So, of course, we want a human able to play with their presentation layer, and then within the D app, a an artificial or computer-driven player. And we want two of those because when no human's busy or whatever, maybe we can pit the two computer players against each other and have the D app evolve. Television, Motorola and television. Um, so how does this D app learn then? What I'm having a problem with is persistence. So the game master says, okay, player two, which is done by the, and that's one more thing than human against human through the network, right? Multi user games. But let's stick with the computer. So the computer says, okay, this is the pattern, and of all the images, what ones are in the set of could be my next turn? But we want it to be able to learn how to play the game so it gets better and better at it. Well, breadcrumbs wouldn't be so hard for a simple game like tic tac toe. But design wise, if we start doing that, then where do we go from there when we want to make a bigger game like chess or Go or something? I say breadcrumbs because between turns, you got this image, so out of all the images you know about, you want to only pick the ones that could possibly be the next. That's why I was talking about like bubbling up or whatever, or a PNG with you know, where you can put in, you have a green screen basically and can put in whatever you want. So it could be we could use caching here, but yeah, the smart agent should be able to learn the turns it made in a game. And sure, we can either brute force or whatever say, oh, okay, this is the set of valid next patterns for this game, and pick one, RNG. But so then either we would need to then get like the human player's turn and say, yikes, I made I made it seemed like a good idea at the time, but it wasn't. So I want to remember that. But how can it evaluate that until the end of the game and somebody won or lost? Which isn't tic tac toe a zero sums game or whatever they call it? That is to say, if you don't screw up, if you started, you're gonna always win, or maybe it's the other guy. Anyhow, so yeah, so each image has an ID, so it says, okay, I've got this image, and I chose this image. See, with my trading bots with like Forex and stuff, we could have the previous price, the current price, and now the next price, because we've made a guess about is it going to go up or is it going to go down. Next price would determine that, so we get a stream of data like that. But with the tic-tac-toe game, it would have to keep track of each image, and so whether it wins or loses, it could go backtrack and reward or punish each one of those images. So the next time we come in and we've got this set of valid images, but they've got weighted experience on them now. So we sort by that and pick one from the top three better choices or better rewarded choices. And therefore, theoretically, one could say that the system is learning how to play tic tac toe. And a good milestone would be can if the computer goes first, thinking that whoever goes first, unless they screw up, will win, or it'll be a tie. Yeah, that could be okay too. So it'll be interesting when and if the system gets itself to where if it has the first move, it'll always win, or if actually a draw, wanted to say match, a draw, isn't that so? If the D app can play a human player to a draw, then it's learned something, sort of, kind of. I don't know. Maybe I'll take a break for a while.